We'll discuss a new topic, that is armature winding. So armature winding in synchronous machine. Armature winding in synchronous machine. Armature winding in synchronous machine. Okay, armature winding in synchronous machine. So there are two options. Either we can connect. You can see that. You can see that if the windings are connected in these three phases are there. Let's say that one is R phase, one is Y phase, and one is B phase here. We can connect. I'm just redrawing again so that you can able to understand in a better manner. So you can connect. There are two options only for us. You can connect in star or delta. If I want to connect in star, I have to close this. Then what is the connection here? Star connection. If I want to connect in delta, so connect like this. So connections are given at the external side. Okay, you can see once you go to the machine slab, you can see that there is a socket outside box is there. 6 terminals will be like there, where with socket box will be there. So we can connect externally. We can decide whether the winding can be a star connection or delta connection. Inside winding, the 3-phase windings will be there. The way we connect, it can decide whether it's a star connection or delta connection. Okay. The manufacturer is giving us the option to decide whether the winding has to be in star connection or delta connection. So here armature winding can be classified in several types here. Single layer winding, double layer winding, full pitched winding, short pitched winding, concentrated winding. Okay. So let's try to write down the classification of armature winding. Classification of armature windings. Try to understand, adjust with my handwriting. So I'll simultaneously explaining also. So armature windings is concentrated winding. And second one is distributed winding. Okay. So try to be fast. Concentrated winding, other one is distributed winding. So where we use concentrated windings here? There is transformer and other things here. Okay, we use concentrated windings here. Distributed is the winding is distributed evenly. Okay, like in DC machines, lap winding and wave winding. Okay, wave winding. Okay, in distributed winding. Okay, here in relevant to the synchronous machines, I am discussing here. To be more specific here. So distributed winding, again here I am saying that full pitched winding. Second one is short pitched winding. So anyone, what is the next classification? Huh? No. It's short pitch winding. Again, it is slots per pole, fractional winding, and next one is integral slot winding, fractional slot winding. Integral slot winding and fractional. Integral. Okay, integral slot winding. Other one is fractional slot winding. Integral slot winding, other one is fractional slot winding. Integral slot winding, other one is fractional slot winding. Okay, so these are the classifications here. So what is the concentrated winding here? We'll try to discuss one by one later. Okay, so if the winding is concentrated repeatedly, then that's a concentrated. If the winding is evenly distributed, that's a distributed winding. Again in the distributed, now we'll try to discuss these concepts now. Full pitched winding, short pitched winding, integral slot winding, fractional slot winding. Okay, integral slot winding, fractional slot winding, I'll just tell in short here. If slots per pole per phase, slots per pole per phase, A by B by C, that is A by B into C. Okay, slots per pole per phase. If the value is integer, if the resultant value is integer, then that's a integral slot winding. Okay, if the value, if slots per pole per phase, if the resultant value is not an integer, then that type of winding is fractional slot winding. Okay, slots per pole per phase. I hope this is the actual classification. Okay, concentrated, distributed, full pitched, short pitched, and again in the short pitched. Okay, integral slot winding and fractional slot winding. So in the first unit of induction motors, so I used a term called harmonics. Okay, so we will try to discuss in detail about the harmonics and how you eliminate the harmonics with this type of winding. One type of harmonics can be eliminated with one type of winding. Okay, so we will try to. I hope it's clear. Okay, these are the main classification. So we'll try to get into the actual terms in detail here. Single layer winding you already discussed. What is single layer winding? One conductor per one slot. I guess you don't need to learn more than this. What is double layer winding? Two conductors per one single slot. Okay, double layer winding. Okay. Now here, what's the major purpose why the double layer winding is preferred? Because to generate more power. So within the same space, if I accommodate why duplex, multiplex or apartments are now famous. The space is same, but I am constructing multiple floors so that I can accommodate more number of people. So similarly, by accommodating more number of windings in single slot, we are able to generate more amount of power here. Okay, we already discussed the EMF equation 4.44 of T. T is nothing but turns. T is indirectly relevant to the conductors or not. So more number of turns, more number of conductors, more amount of EMF. Okay, this is single layer winding and double layer winding. So I guess there is no need to tell again here. We can generate more amount of power here. Okay, ultimately the main conclusion is we can able to generate more amount of power the same space. So we will try to discuss some basic definitions here. Okay, before we proceed into the pitch factor and distribution factors. Just quickly make a heading pole pitch. Pole pitch. Make a heading pole pitch. What is pole pitch here? The distance between the two centers of the pole is called as pole pitch. The distance between the two centers of the pole. We already discussed this in the DC machines. Okay, the distance between the two centers of the poles here. So obviously it is in terms of electrical angle. We are discussing about in terms of electrical angle. I guess everyone knows the basic difference between theta electrical angle and mechanical angle. Theta electrical equal to P by 2 into theta mechanical. Theta electrical equal to P by 2 into theta mechanical. Okay. So for a 2-pole machine, the electrical angle is same as the mechanical angle. For a 4-pole machine, it is double. Okay. So always each pole covers 180 degrees of electrical angle. Each pole covers. We already discussed this in DC machines. If you want to rewrite, it's up to you. Okay. It will be better. Okay, now always each pole covers how much electrical angle? 180. Though it's a 4-pole machine or 8-pole machine or 10-pole machine, each pole covers 180 degrees of electrical angle here. Now here the distance between the centers of the two poles is called as pole pitch. If it is a north pole and this is south pole, and the angle here it is pole pitch here. Okay. What is the formula here? Just quickly write out here. Pole pitch is equal to total number of slots per pole. So it is S by P. In short, we'll write it as slots per pole. Number of slots per pole. Okay. Slots per pole here. If slots are 24, okay. If slots are 24, okay, and if slots are 24 and poles are 4, if slots are 24 and poles are 4, then what is pole pitch? 6. So pole pitch is 24 by 4 here, that is equal to 6 here. 24 by 4 equal, that is equal to 6. Okay. So already told you that pole pitch is, okay, always pole pitch, okay, if I want to consider in terms of electrical angle, it is 180 degrees electrical angle. It is 180 degrees of electrical angle. Pole pitch is always 180 degrees of electrical angle. Next, we will try to discuss, we already know this basic term here. Coil can be single turn coil or multi-turn coil. Okay, this is a single turn, okay, 3 turn. What is 3 turn here? That means 3, okay, 3 into 2, 6 coil surts are there. Single turn is nothing but how many coil surts are there? 2. Coil side or conductor, both are same. Just go through all this, okay, this basic terms here. So because it's a continuity here. What is coil span here? Next definition here. Coil span is nothing but it is a distance between the two coil sides of a coil. It is a distance between the two ends of a coil. It is the distance between the two ends of the same coil is called as coil span. So from here to here, okay, from left side to the front end to the back end. We use a term called front side, back side, okay. From front side to the back side, what is the distance? Okay, that is nothing but coil span. How it will be measured? There are only two options. Between these two, what are there? One is slots are there, and I can also measure in angle. There are two options for me. I can measure the slot, this coil span in terms of slots or in terms of electrical angle. In terms of slots or in terms of electrical angle. Okay, in terms of electrical angle. Okay. So we are all learning these basic terms for the pitch factor concept here. And one more concept, slot pitch. The phase angle between the two adjacent slots. The phase angle between the two adjacent slots is called as slot pitch. The phase angle between two adjacent slots here. Okay. So if we'll try to represent the formula here also. Slot pitch is 180 by S by P. Slot pitch formula is 180 by S by P here. Slot angle. Sorry, it is slot angle. Okay, we'll try to make a separate heading and we'll try to discuss here. Okay, you can write. I hope we discussed coil span. Okay, another one is slot pitch and slot angle. Next, we'll try to write one more term called slot angle. Slot angle. That means how much area each slot covers. How much area each slot covers. Okay, one person may be 40 kg weight, one person may be 100 kg weight. Can I able to consider both as same? No, it depending upon the weight, we'll try to consider weight, say thin or okay, heavy person. Similarly here also, how the slot winding, how the slot is accommodated, what is the distance here, how much area it is covering here. It is mainly depending upon angle here. Okay, that is slot angle. That is slot angle here. So slot angle is nothing but, what is the formula here? 180 by S by P, slots per pole. 180 by S by P. We'll try to represent slot angle as alpha. Okay, each textbook may be having different notations. Okay, we'll try to consider the basic one here. So I'll go with the alpha here. Slot angle equal to 180 by S by P here. Okay, so once we actually get into the topic, it will be easy for us to mix all these things and get into the conclusions here. Shall I proceed? So now we will try to discuss. We try to get into this is the basic classification between the which case? Second case here. In the concentrated winding and distributed winding. In the distributed there is a subclassification. What is the subclassification? Full pitched and short pitched. Now we are discussing about full pitched winding and short pitched. What is the definition here? Full pitched winding. You can simply just by going through this, we can easily understand here. Full pitched winding is nothing but if the coil span is equal to the pole pitch, then it's a full pitched winding. If the coil span, what is coil span? The distance between the two ends of the coil is nothing but coil span. What is pole pitch? The distance between the centers of the two consecutive poles. The distance between centers of the two consecutive poles is nothing but pole pitch here. If both are same, if the both are same, then it's called as full pitched winding. So a simple example, the actual cross strength is 67 and the present is at 67. I can say that full attendance is there. Yes or no? Okay. Full attendance is there. That is indirectly full. Okay, which is rare. Okay. Full attendance normally present in the exams. Okay. Whereas short pitched is nothing but class strength is 67, but actual strength is below 67. Okay. So let's try to correlate here. If the coil span is equal to pole pitch, which is equal to 180 degrees. We can also write here, which is equal to 180 degrees electrical. The coil span is equal to pole pitch, which is equal to 180 degrees electrical. Then it is called as Nd. We can call it as pole pitch. We can call it as full pitch. Sorry, we can call it as full pitched winding. We can call it as full pitched winding. Okay. If one winding is placed here and the other slot is placed here. Okay. If the distance between these two is 180 degrees, then by default I can consider this winding as full pitched winding here. Full pitched winding. Okay. Each pole covers how much electrical angle? 180 degrees. Okay. Each pole covers 180 degrees of electrical angle. In this manner I can able to calculate here. Now here, how the voltages will be added here? Okay. Here in this case, slot 1, slot n plus 1. Here the voltages are added in arithmetic sum. Most important here, the important point is here voltages are, I hope you can able to see here. Okay, voltages are added in arithmetic sum. Here voltages are added in arithmetic sum. They may ask you the comparison between full pitched winding and short pitched winding. In such cases, you have to draw the diagram and you have to convey them. Okay, just the voltages, what are the voltage windings that are generated here? Let's say that this is one E1 and this is E2 here. How the voltage, both voltages are added here? Arithmetic sum directly. 2 plus 3 equal to directly 5. There is no confusion. Directly the voltages are, the maximum voltage will be generated and the voltages are directly added in arithmetic manner. And why I am specifying particularly, because there comes the next case here where the voltages are not added in arithmetic. You can see the second case here. What is the heading here? Short pitched winding. The second one is short pitched winding. What is short pitched winding here? If the coil span, simple, you can simply write this word here. If the coil span is less than pole pitch, if the coil span is less than pole pitch or less than 180 degrees, then it's a short pitched winding. If the coil span is less than pole pitch or less than 180 degrees, then it's a short pitched winding. Okay. Then it's a short pitched winding here. Okay. You can see this. Actually, in full pitched, suppose if I'm placing here in the first slot. Now I am placing the other end of the coil in the 9th slot. What is the coil span here? 9 minus 8. That is equal to 8 slots. In terms of slots, it is 8 slots. So in order to get the full pitched winding, I have to keep the other winding in the 9th slots. Now here, someone will say that, sir, why only 9? Why cannot I able to reduce my count? Okay, why cannot I keep in 8th slot or 7th slot? What actually happens? Yes or no? That is about research. Yes or no? What? So instead of keeping the slot in the 9th slot, okay, the winding in the 9th slot, I'm keeping somewhere at 7th or 8th. Now here, what is happening here? Is the coil span is now 180 degrees now? What is coil span? The distance between the two ends of the coil. Previously, the distance is 180 degrees, which is equal to pole pitch, and we can consider directly it as full pitched winding. Now the distance is somewhere 160 degrees. Now is it less than 180 or not? As it is less than 180 degrees, I can call it as short pitched winding. I'm calling it as short pitched winding. So I hope that you understood the basic differences between full pitched winding or short pitch. It's not like a rocket science. Only thing is you have to listen to the class. Then only it will be easy for us to understand. Once you listen clearly, you can you don't need to by heart or you don't need to do anything. Just revising once, it will help you that. This is the basic difference between full pitched winding and short pitched winding here. Okay. So what actually happens here in the short pitched winding? The voltages now are ready to, because previously exactly 180 degrees phase opposition here. Here E1 is upwards and E2 is downwards. Both are adding each other. Now as I am reducing the other winding slots, other winding keeping the less number of slots. So that what is happening here? Now EMF induced will be not arithmetic manner. It is in which case here? Voltages are added in the short pitch winding in which case? Phase or manner. This is also important. Try to write down here. Voltages are added in phasor manner in short pitched winding. Voltages are added in phasor manner. Okay, so 2 plus 3i, what is the resultant value? Magnitude value under root of 2 square plus 3 square. Similarly, I have to do this. Phasor manner means I have to do this. Okay, what are the voltages are there? Each component is there, E1, E3, E5, E7. So I have to add, I have to square them and add them and square root of them. Okay, that will be the basic difference between full pitch winding and short pitch winding. Next. Advantage, you may expect this for 2 marks. Okay, you may expect this for 2 marks here. Okay, expect this question. Okay, now advantage of short winding. Okay, short pitch winding or cord. Okay, you will come to what are the other terms for this. Okay, cording winding. Okay, corded, short pitched or corded. Okay, reduced. So what actually happens here? Copper is saved. Okay, so compared to placing, okay, whatever the length that is here, I am using another color so that it will be easy. So whatever the winding that I am placing from here, now it is reduced here. Yes or no? So what is this additional space here? Is the copper, is small amount of copper is reduced or not? Yes or no? For each winding, if I reduce this small amount of copper here, for the total whole machine, will I be reducing the huge amount of copper? And when copper is reduced, copper cost is also reduced or not? So the overall cost will be reducing or not? So this is one of the advantage. Copper is saved. Okay. Second one is mechanical strength is increased because it is well mechanically balanced. Mechanically, it is more mechanically balanced here. And because EMF induced EMF, its EMF induced will be reduced here. Amount of EMF induced will be reduced, not increased here. Improve the total content. So previously, if full pitched winding, if I say that 100% is amount of voltage is generated, in case in full pitched winding, if 100% of voltage is generated, with the short pitched, we can able to generate only not equivalent to 100%. We can able to generate with reduced voltage. Okay, we can able to generate reduced voltage. It may be 70 or 80 or 90. We'll try to discuss that. Okay, reduced winding. Okay. Okay, yeah. We just now discussed. Okay, we already discussed this basic terms. What is slot angle? Slot angle equal to 180 by S by P. How much slot area covered by the slot in terms of electrical angle? All these are in terms of electrical angle only. Try to understand here. All these are in electrical angle. You have to use theta electrical equal to P by 2 into theta mechanical first. Then you have to go through all these remaining things here. For a 6-pole machine, what is the electrical angle? 6 by 2 into 18 P by 2 into 360. What is the answer? Theta electrical P by 2 into theta mechanical. Okay. So 6 by 20, it is 3 times that of the mechanical angle. That is 360 into 3. How much it is? 1080. It is 1080 here. Okay, we'll try to continue with the definition of pitch factor. Okay. Pitch factor, it is also called as coil span factor or short chorded factor. Okay, in the exam, just to confuse you, they may give the other terms also. Okay, it is also called as coil span factor or short chorded factor. Okay, what is pitch factor here? We just now discussed the basic difference between two cases here, full pitch winding and short pitch winding. Okay, when you have two cases here, definitely we'll try to compare. Yes or no? When you have two cases here, we definitely will have. If you have two sections here, A section and B section, you will ask that which subject faculty is better. Okay, which how it is going in the others. So similarly here, what I am doing here, I am trying to compare the voltage generated in the two cases here. The voltage generated in the short pitch winding by voltage generated in the short pitch winding by voltage generated in the full pitch winding. Voltage generated in the short pitch winding by voltage generated in the full pitch winding will give us the pitch factor. Okay, we just now discussed that. So the voltage generated in the short pitch winding, how it is represented here? It is represented in which form? Vector sum or phasor sum? Phasor sum or vector sum? It is depending upon phasor sum or vector sum. Whereas pitch factor in the full pitch winding, it is arithmetic sum. It is arithmetic sum. Okay. So actually the voltage which should be like this, E1 and E2. Okay. It is shifting like this. It is shifting like this. Okay. The dotted line represents that it is full pitched winding. Okay. When it is shifted here, it means that it's a short pitched winding. Now we'll try to use all the maths here, basic maths, simple trigonometry. Okay. Sin theta opposite side by hypotenuse, cos theta adjacent by hypotenuse, tan theta opposite by adjacent. We'll try to correlate, and if it is alpha, and it will be alpha by 2, and this is also alpha by 2. And once we divide, it will be a right angle triangle here. Okay. So the angle will be as per the trigonometry. If it is, what is this here? Okay, yeah, I forgot to specify. Try to represent this as, okay, I'll try to write here. Try to write slot angle as gamma. Previously I have used another term here. Just try to make the changes here. We'll try to follow what is there in the PDF. And short pitch angle. There is one more term called short pitch angle. It is represented in alpha. We'll conclude in 5 minutes. Okay. Short pitch angle. Short pitch angle is nothing but alpha. Okay. So what is short pitch angle? Okay, I'll try to just represent here. Listen, if there are 6 slots are there, if the first coil is placed under the first slots, okay, it's like this. 1, 2, 3, 4, 5, 6, and coil other end is placed under the 6 slots. Okay, so I'll try to insert. Okay, 6 slot. Then what is the coil span here? Okay, I'll try to add 6, 7 here. Here 6 and this is 7 here. Coil span equal to 7 minus 1, that is equal to 6 here. Okay. So what is the slot angle here? 180 by slots per pole. How many poles are there? Only one pole is there. 180 by 6. Each slot covers how much angle? 30 degrees. Each slot covers 30 degrees. Okay. Now what I am trying to do here, instead of placing at the 7th slot, listen, okay, instead of placing at the 7th slot, I am keeping the winding in the 6th slot. I am keeping the winding in the 6th slots. So I am keeping the winding in the 6th slot. Now listen, see here, I am keeping the winding in the 6 slots. Okay. So this is short pitched. This is short pitched winding. In short pitched winding, the first coil is placed on the first slot, and second coil is placed under which slots? 6th slot. Okay, second coil is placed under the other side, is placed on the 6th slot. What is coil span now? It is distance between the two ends here. It is, previously it was 7 minus 1. Now it is equal to 6. Now it is 6 minus 1, which is equal to 5. Each slot covers how much angle here? What is slot angle? For full pitch it is 30 degrees. We already discussed. We already calculated 180 by S. 180 by slots per pole here. Okay, that is equal to slots per pole. Okay. Now here it is 30 degrees. How many slots are there here? 5. That is equal to 150. That is equal to 150. So I can conclude that if for a full pitched winding, the coil span equal to 30 into how many slots are there here? 6. What is the angle here? 180. So what is 180? 180 is equal to pole pitch or not? 180 which is also equal to pole pitch. 180 which is also equal to pole pitch. Okay. 180 which is also pole pitch here. Let's try to conclude this. Okay. So if coil span equal to 180 degrees, which is equal to pole pitch. Okay. That is equal to what we can say that it is full pitch winding. If the coil span, okay, whatever we got just now. So previously how many slots we got here? We got 6 slots. 6 into 30, that is equal to 180. Now here we have only 5 slots, 5 into 30 degrees. How much here we are getting? 150. 150 which is it less than the full pitch winding or not? So this is called as short pitched winding here. I am concluding the things here. What is this? What this coil span? Coil span is represented with beta. Remember and write. Okay. This coil span is given notation with beta here. Okay. And short pitch angle. What is short pitch angle here? This is a new term. Short pitch angle is nothing but how much angle deducted, how much angle reduced with the shifting of the coil. Previously it was 180. Okay. And it is reduced to 150. Now how much angle has been reduced? 30. Or else you can also say that how many slots have been reduced? 1 slot or not? Or 1 slot reduced. That is equal to slot angle which is equal to 1 slot angle which is equal to 30 degrees. So this short pitch angle which is represented with alpha is called as short pitch angle, which is also called as short pitch angle, which is also called as short pitch angle here. I hope it's clear. What is the difference between coil span and short pitch angle? Short pitch angle is nothing but okay, how much angle has been reduced, that we call it as short pitch angle. Okay, coil span is nothing but how much the distance between the two coils, how much these two coil ends are been spreading or separating. Okay, now how much distance it is covering, that is called as coil span. What is pole pitch? It is 180 degrees. It is 180 degrees. Can I make the relation between these 3 parameters? Can someone tell me? What is the relation between these 3? I can say that I will conclude here. Coil span plus short pitch angle equal to pole pitch. Coil span which is beta, short pitch angle which is alpha, which is equal to pole pitch. Am I correct or wrong? In full pitch winding, if you see in full pitch winding, what is coil span beta equal to? 180 degrees. And what about the short pitch angle? Short pitch angle, this is not the case. For full pitch winding, there is no reduction here. Alpha short pitch angle equal to 0. In short pitch case here, coil span which is equal to beta equal to how much angle it is? 150 degrees. Short pitch angle equal to 30 degrees. 150 plus 30 equal to 180 or not? Which is equal to pole pitch. So always the relation lies here. Okay, I can say that the coil span, if the coil span is equal to 180 degrees, by default the short pitch angle is 0. Out of in class, if out of 67 students, if 67 students have been passed, what does it mean? How many students have failed? 0. Similarly, for a full pitched winding, short pitch angle is 0 here. For a short pitched winding, you can see the heading itself. Full pitched winding, short pitched winding. For a full pitched winding, is there a short pitch angle? No. For a short pitch winding, how much short pitch angle exists here? That I can go to calculate with the difference between the full pitch angle, that is 180 degrees minus. If I want to find out short pitch angle alpha equal to, how can I calculate? Pole pitch minus. I can write here alpha plus beta equal to 180. If any one term is known, I can able to calculate the other term for short pitch angle. Alpha equal to 180 minus beta. Alpha equal to 180 minus beta. What is alpha here? Short pitch angle. Just you need a little bit practice for this. Let's conclude. Okay. So this alpha is What is this alpha? Short pitch angle. How much it is reduced? That is alpha is short pitch angle here. By considering the trigonometry here and by simplifying here, Kp equal to EMF induced in the short pitch winding by EMF induced in the full pitch winding here. Ultimately, what I am trying to do here, I am trying to find out this length, A, C, B length. I am trying to find out AB length. For that, I am dividing the length into two parts. I am dividing the length into two parts. One is AC length, BC length. How I am trying to find here? Already I know this is alpha by 2. This is 90 degrees. What is this angle here? It is opposite side. Okay, this is okay to the angle. This is adjacent side. So it will be in terms of cos. So just revise this basic maths terminology, and so that you will get AC to AC value. You will get it as just it's a matter of time. AC value will get it as AC equal to you will get it as AD into cos alpha by 2. What is cos theta? Adjacent by hypotenuse or not? This one is adjacent. Okay. This one is hypotenuse. This one is opposite. So cos theta equal to adjacent by hypotenuse. And if I want adjacent value, hypotenuse into cos theta. What is cos angle here? Cos of alpha by 2 into AD. What is this length here? It is AD. This length, AD length. Similarly, we can also calculate the BC length also in the same manner. Okay. So by adding these two, we can able to get here. So you can write here Kp equal to 2 into AD into cos alpha by 2 by 2 into AD. Why in the denominator directly? Why I am adding directly here? Because it is arithmetic sum. All the voltages are in the same magnitude. So that directly E1 plus E2, which is equal to E, directly it is added here. You can able to get this clear data in the PDF, which is in the easier manner. Okay, once so 2AD and AD gets cancelled. So what I'm left with here, Kp equal to cos alpha by 2. This is the pitch factor conclusion. Pitch factor formula is cos of what is alpha there? Short pitch angle, half of the short pitch angle here. Cos of half of the short pitch angle here. Okay, half of the short pitch angle. So ultimately pitch factor is how much voltage, the voltage generated in the short pitch by the voltage generated in the full pitch. Okay, we'll just conclude this class now.